A lot of people think the next decade will be decided by software, or AI, or chips, or energy, or defense, or industrial policy. But underneath all of that, there is another layer: materials, critical minerals, lithium, copper, nickel, cobalt, rare earths, graphite, and other industrial inputs that most people rarely think about until supply gets tight. That is the shift. The next decade may not be decided only by who has the best technology. It may also be decided by who can secure enough of the materials that modern technology depends on. That is why critical minerals may decide the next decade. Not because minerals are glamorous, but because more and more of the systems that define modern power run through supply chains built on them. People often treat minerals like an old economy story. Something about mining, something far away, something environmental, something technical and obscure. That misses the point. Critical minerals are no longer just raw material inputs sitting at the edge of the economy. They are increasingly at the center of it, because the systems that now matter most depend on them. Electric vehicles depend on them. Battery storage depends on them. Power infrastructure depends on them. Semiconductor equipment depends on them. Defense systems depend on them. Industrial electrification depends on them. Advanced manufacturing depends on them. That means minerals are not peripheral anymore. They are foundational. And once something becomes foundational, control over it starts shaping strategy, investment, and geopolitical power. One of the biggest reasons minerals matter more now is the energy transition. If economies want more electrification, more renewable build-out, more storage, more EV adoption, and more grid expansion, then they need huge amounts of material. Copper for wires and transmission, lithium for batteries, nickel for battery chemistry, graphite for battery anodes, rare earths for magnets, other metals for industrial systems that make electrification possible. That matters because energy transitions are often described in abstract terms. But abstract transitions still need physical inputs, and physical inputs create bottlenecks. So the real question is not only can countries commit to electrification, it is, can they source enough of the materials required to build it? That makes the minerals question much more strategic than it first appears. This is not just an energy story. It is also a digital infrastructure story. Data centers need power hardware. Grid systems need upgrades. Semiconductor production needs specialized inputs. Advanced electronics depend on complex materials chains. High-performance computing depends on manufacturing systems that sit on deep material networks. That matters because people often separate the digital economy from the extractive economy, but they are connected. The digital layer still depends on physical systems underneath it, and those physical systems depend on mining, refining, processing, transport, and industrial materials. So even the industries that feel most futuristic still run through the ground. That is another reason critical minerals matter so much. They link the digital future to the industrial base beneath it. The world has minerals. That is not the only problem. The deeper issue is concentration. Where are minerals mined? Where are they processed? Who refines them? Who controls midstream capacity? Who dominates export routes? Who has the industrial ecosystem to turn raw inputs into usable materials? That is where power sits. Because supply chains can be fragile even when resources exist in theory. A country may have a deposit, but not processing capacity. A company may have access to raw material, but not secure refining. A region may want build-out, but depend on overseas bottlenecks to get the components it needs. This is why the minerals issue is not simply about what is in the ground. It is about who controls the chain from extraction to usable industrial input. And that is a much more strategic question. This is one of the least understood parts of the story. Mining gets attention, but processing may be even more important. Because raw material is not the same thing as usable industrial input. Material often has to be refined, separated, chemically processed, purified, and turned into forms that manufacturers can actually use. That creates leverage. Whoever controls processing can shape access downstream. That means the country or company with the mine is not automatically the one with the most power. The power may sit with the one that can process at scale, reliably, cheaply, and with the industrial ecosystem to support it. That changes how the mineral story should be understood. It is not just a resource story. It is a processing story. Because critical minerals sit so early in the chain, tightness here can ripple outward. If minerals tighten, battery costs can shift, grid upgrades can slow, defense procurement can get more expensive, advanced manufacturing projects can face delays, supply chains can become more politically sensitive, industrial strategy can become more defensive. That is important, because early-stage bottlenecks often look small at first, but they spread widely. A constraint in one mineral stream can affect many industries at once. That is why this is not a niche issue. It is a multiplier issue. The more sectors depend on the same material base, the more powerful those bottlenecks become. And that is exactly what is happening now. Once something becomes strategic, policy follows. That is why governments are now paying more attention to critical minerals, not only through rhetoric, through subsidies, industrial policy, stockpiling, trade controls, processing support, domestic mining efforts, and efforts to secure alternative supply chains. That tells you something important. Countries increasingly see minerals not just as commodities, but as strategic inputs. That is a major shift, because it means the minerals market is becoming more political. And when a market becomes more political, pricing, access, and investment all become more unstable. This is another reason the next decade may be shaped by minerals more than people expect. The competition is no longer just commercial, it is strategic. For a long time, globalization pushed firms toward lowest cost. That logic still matters, but in strategic sectors, security is now rising in importance. Can the supply be trusted? Can it survive a geopolitical shock? Can it keep moving during trade conflict? Can it support industrial goals over time? Those questions matter more now. That means firms and governments may increasingly accept higher cost in exchange for more secure supply. That is a real economic shift, because it changes how sourcing decisions are made. The cheapest material stream is not always the most valuable one if it creates strategic vulnerability. So the minerals question is not only about abundance, it is also about resilience. And resilience is often more expensive. If minerals become strategic, industrial policy changes too. Because a country cannot easily say it wants battery leadership, AI infrastructure, advanced manufacturing, or energy transition leadership without also asking where will the material base come from. That turns minerals into an upstream industrial policy problem, not an environmental side issue, not a background commodity issue. An upstream industrial question that changes how countries think about trade, alliances, processing, permitting, investment, and supply chain strategy. Because the real build-out depends on what sits under the build-out. And if that layer is weak, the rest of the strategy weakens too. A lot of the most important constraints are not dramatic. They are quiet: permitting delays, processing gaps, refining concentration, transport challenges, community resistance, capital discipline, environmental compliance, long project timelines, equipment shortages. These are not flashy headlines, but they are exactly the kind of things that shape the next decade. Because industrial change often moves only as fast as the quietest choke point in the system. That is why minerals deserve more attention. They sit at the intersection of geology, industry, capital, policy, and time. And time matters here. You cannot instantly build a mine. You cannot instantly build a processing ecosystem. You cannot instantly create secure supply. That means whoever solves these bottlenecks better may gain a major long-term edge. The next decade will likely demand more material-heavy build-out than the previous one. More batteries, more grid expansion, more electrification, more digital infrastructure, more advanced hardware, more defense production, more industrial redundancy. That means more pressure on the material systems underneath it all. This is the deeper pattern. Modern economic power is becoming more dependent on upstream physical inputs than many people expected. and critical minerals sit right there. That is why they may decide more than just one industry. They may help decide which economies can actually execute the future they are promising. Critical minerals may decide the next decade because they sit underneath too many systems that are now considered strategic. The energy transition runs through them. Digital infrastructure runs through them. Advanced manufacturing runs through them. Defense capacity runs through them. Industrial policy runs through them. That is the deeper pattern. The future may be sold through software, AI, and electrification, but it will still be built through material chains that are slower, harder, more concentrated, and more political than the surface narrative suggests. And when upstream inputs become strategic, the whole map of economic power starts to shift. The next decade may look digital, cleaner, smarter, and more automated. But underneath that future, the old reality still remains. You still need material. You still need extraction. You still need processing. You still need industrial coordination. You still need supply security. That is why critical minerals may decide the next decade. Not because they are new, but because the world is becoming more dependent on them all at once. And when dependence rises faster than supply security, the quiet material underneath the system can end up shaping everything above it.